Hello, lovely Year 12s. Today we're going to continue on with vector calculus. In the previous episode, we had a look at how to differentiate and integrate vector equations, and that gave us, displacement, velocity, acceleration. Now we're looking at different types of motion that we might find. So in this example below, this is an example of projectile motion. We might have some examples where we might have, say, circular motion, or it could be elliptical motion, where it's moving around more an oval shape. We could have really any type of motion. It might look something like that and just repeat itself over and over and over again. It's sort of like limitless what the sort of motion is that you might particularly find. And so I'm just going to go through two examples here. There's a lot of different styles of questions in this chapter here. There's also one where there's, which I'll do a separate video for, projectile motion up an inclined plane. So that's a scenario where you've got an inclined plane like that, and then you projectile something up, and then it sort of comes down. Like you want to find out where it sort of hits that plane there. That's a little more complicated, that style of question. I'll do that in a separate video for you. So I'm just looking at a simple projectile motion sort of question here, and then I'll do an exam style question where we have that particular type of motion there. So for this example here, what we've got is projectile motion. So a particle is projected from a point on a horizontal plane at 30 degrees above the horizontal with an initial speed of 50 meters per second. It experiences constant downward acceleration due to gravity. And we're going to assume that gravity just 10 in the vertical direction. So, and then it wants us to first of all figure out, well, what is the acceleration vector for that one there. So I can just say first up, okay, well, my acceleration vector is equal to, it's just going to be constant. There's nothing horizontal about it, but it will be minus 10 because it's going to go downwards in that direction there. And actually, I could write that's actually acceleration in terms of time there. So that's just constant. It's always just going to be down regardless of the time. So now I can figure out, well, what is a velocity vector? So here we could say, well, what is the velocity initially? So at time t is equal to 0, what's it going to be equal to? Well, it's got a velocity of 50 meters per second at an elevation of 30 degrees. So that's really just going to be, well, the horizontal component is going to be 50 cos 30, and the vertical component is going to be 50 sine 30, because really you've got a your right angle triangle there, 30-degree angle, with a magnitude of 50. So that simplifies down to, what are we going to get there? 50 cos 30 is going to be 50 root 3 over 2, so it's going to be 25 root 3, and sine 30 is a half, so that's just going to be 25 there. So there's our initial velocity. And we know that the velocity at any particular time is the integral of our acceleration vector with respect to time. So let's go ahead and integrate that there. That's going to be equal to 0 and minus 10t, like that there, plus some constant amount. Now we know initially we've got that amount there. So what are we going to get? We're going to get 25 root 3 and 25 take 10t, like that there. Part C of the question saying, find the velocity of the particle t seconds after this projection. oh yeah, sorry, yep, so we just had done that there. So I'll just write this out here. This was our part A. We found its initial, and then we found it after a particular point. And for the final part, the time taken for it to reach its highest point. So when it reaches its highest point, the vertical component of the velocity will be 0. So if we picture, let's just draw that here. So that particular point there, when it reaches its highest point, it's still moving across horizontally, but the vertical part is going from moving up to now stationary, and then it'll start moving down. So I want to find where that 25 take 10t is equal to 0. So for part D here, I want to find when vertical component of velocity equals 0. So that's when 25 take 10t is equal to 0. So that means 25 on 10 is 2.5. So when t is equal to 2.5 seconds, let's have a look. Yeah, meters a second, so that is seconds there. The time taken to reach its highest point, yeah, so it'll just be after 2.5 seconds. And then, you know, if you integrated that velocity vector, it will give you displacement, and you could figure out how far it will go after a particular point. But yeah, so that's that particular example there. Now what we're going to do is we're going to have a look at an exam style question. So this has some easy components and some more challenging components too. Okay. So I'll just zoom in a bit as well. Alrighty. So we've got a path of a particle is shown there. The position vector, so we're given a position vector, and t has to be greater than or equal to 0. Okay. I might actually just go ahead and show how this looks on the class pad as well. So what I'm going to do here is go to my back up here. I'm going to do a new share. I'm going to get the class pad, and let's go ahead and put that particular just going to bring it over there so I can see. All right, so I'm going to go to menu, graph and table, type, parametric type, 3 take 3, sine t, shift 1, and I have to put in the actual t here. And then I've got here 2 cos t, take sine 2t. Cool. And then you need to go ahead and go from 0 to, you know, whatever particular value you want. From the original question, you're sort of going from, let's change this from, let's just say -2 to, like, say 9, and I'm going to go -3 to 3, and let's go ahead and graph that. That is not what it looks like. So 3 take 3 sine t 2. Oh, messed that up. Okay, let's try that again. Okay, 2 cos t take sine 2t. There we go. Cool. So that's similar to what we've got in the diagram, to the diagram there. Wonder if we can do it more slowly. Not sure if we can really. maybe if I make it go longer. All right, so it's hard to see there, but anyway, you've got the gist of it there. Now I'm just going to go back to our question here. So you can graph it on your class pad. This is a calculate question. Determine the initial position. So that's when we basically just need to substitute in 0. And what are we going to get here? We're going to get, well, just 3 there. And cos of 0 is 2, cos is 1, so 2, and yeah, so we're just going to get 3, 2 there. Nice and easy. So just remember initial position is t is equal to 0. Determine the acceleration vector for the particle at the instant it first reaches the origin. So let's have a look here. So I'm assuming it's going, well, it's going one way or the other. So it's going to go, all the way around. So when it first reaches the origin, it appears that both the horizontal and the vertical component is going to be equal to 0. So that means that at the origin, so either we can say that horizontal component is going to be 0 or the vertical component is going to be 0. However, just looking at it, that horizontal component equaling 0 is going to be much easier to work with. So x is going to equal to 0. So therefore, 3 take 3 sine t is equal to 0. So that means sine t is going to equal to 1. And so that means t is going to equal to pi on 2 to get us that particular value there. So at pi on 2 seconds is when it's first going to reach the origin there. And actually, sorry, let's just confirm that. So we're going to go back to the class pad here. If I go in and I change it to up to pi on 2, so I'm going to put in here pi divided by 2. Let's see what it does. Maybe I made an error here. Let's try for pi and see what happens. Oh yeah, so yeah, no, I was right. So essentially what it does is pi on 2, just trying to make sense of this. Yep, so it starts at the 3, 2, like we said, that's its initial position, and then it first reaches it at pi on 2 down there. So it starts here and then it works its way around. So we've done that right. So determine the acceleration vector when the particle first reaches the origin. So we figured out the time. Now we've just got to come up with the acceleration vector. So we know that velocity is just going to be the differential of that one there. So that's just going to give me, if I differentiate, sine turns into cos, so minus 3 cos t. And cos goes to the negative sign, so minus 2 sine t. And sine goes to cos, so minus 2 cos 2t. So we've got that there. And then we can go, all right, well, our acceleration vector, we're just going to differentiate again. So cos goes to negative sine, so it's going to be 3 sine t. That sine goes to cos, so minus 2 cos t. Cos goes to negative sine, so plus 4 sine 2t, like that there. And so now we just want to do the acceleration of at pi over 2. And if we put that in there, sine of pi over 2 is 1, so it's going to get 3. Cos of pi over 2 is equal to 0. Cos of sine of pi is going to be sine of pi 0. So yep, so it's going to have our point there at that particular location. I just want to just check that there. Yep. So I've done that right there. So its acceleration will just be a horizontal, so it's just moving out, and that sort of looks like it makes sense. So initially, it's just going to move out at 3 meters per second. Out to the left there, out to the right. So now determine the distance traveled by the particle from the time it leaves its initial position until the first time it reaches the origin. So basically, I want to, coming back to have a look at the class pad here. New share. Oops. Sorry, I've been sharing the screen the whole time. So basically we want to find that particular distance there. I'm just going to come back here. Apologies. So what I did back here was we figured out it was pi over 2. I differentiated the here to get that vector. I then did the acceleration here and I substituted in the value there. Apologies about that. So now we want to figure out, well, what is the distance traveled from when it leaves its initial position. So let's just check I'm on the right share screen here. Yep, I'm on this one here, so that's good. All right, so in the previous one, I got you to think about, well, what does those 3 particular scenarios where you integrated velocity and when you did absolute value. And we said that if we did the integral of the absolute value of the velocity with respects to time, that is going to give you the distance. So we want to know, well, when's that going to be between? And so from 0 to pi over 2 seconds, so I'm just going to go here, pi over 2 and 0. That'll give us that particular value there. So let's have a look here. We want to firstly figure out what's the absolute value of our velocity. So I want to figure out what is that going to be. Well, that's just simply going to be, get a big one of these here. So minus 3 cos t all squared plus minus 2 sine t take 2 cos 2t all squared. Okay, so now if I integrate that from 0 to 2, that'll give us our value there. So let's just go ahead and do that on the class pad. All right, so it's going to share my class pad screen here. And I'm going to go ahead and put that in. So you can't see the background there, but I can. So what I'm going to do here is go to main. I'm going to clear everything that I've got there. And so essentially what I want to do is I want to I'll get my keyboard up. I want to do an integral. I want to do that integral from pi over 2 down to 0. And I'll just do this in terms of x, that's fine. All right, so what have we got here? Integral of, so our first one was minus 3 cos x squared plus, and then the other one was minus 2 sine x take 2 cos 2x all squared again. Alrighty. 3.63. Let's write that down there. So let's come back here and go back. 3.63. Does that sound about right? Let's come up here and have a guesstimate. So we're saying it starts at 3, 2, which is about there. So we're saying, is that about 3? So if we were to pretend that that was a straight line where that was 3 and 2, that would be 9 for root 13. Let's just double check what root 13 is. I'm going to look it up on just my phone calculator here. Square root of, still on ClassPad, here we go. Square root of 13 is 3.6. So 3.6, so we got an answer of 3.63. That sounds about right, what I've done there. So I can sort of like guesstimate what's that's going to be. All right, final bit here. This is a bit of a doozy. Find a Cartesian equation of the path of the Cartesian equations given by that form there, and we will find the constants A and B. Okay. So none of this requires any of the previous parts. I'm just going to come back up and rewrite out the equation. 3 take 3 sine t. Oh. Oh. What's happening? 3 take 3 sine t. Oh. And 2 cos t. 2 cos t. Take sine 2t. Cool. So I've got that there. And we also know that we've got, okay, so ay squared plus bx plus 4x squared is equal to 0. So we want to turn one into the other. Okay, so first of all, we can say, well, x is equal to 3 take 3 sine t, and I can say that y is equal to 2 cos t take sine 2t, because our position vector is an xy, that's an x component, that's a y component. All right, let's go through. Okay, so I can factorize this one here. That's going to give me 3 outside of 1 take sine t. I can factorize out here. Well, actually, can't factorize anything yet because I've got the double. I can use the double angle identity and say that that's going to equal to 2 sine t cos t, and then go, all right, I'm just going to factor out 2 cos t out of both of these, and I'm going to get 1 take sine t, like that there. Okay, and you go, oh, this looks pretty good. This looks pretty good. So I can say that, well, 1 take sine t is equal to x over 3. I can say that over here, 1 take sine t is equal to y over 2 cos t. And then I can go, alrighty, well, knowing that, I can go that x over 3 is going to equal to y over 2 cos t. So then I can go 2x cos t is equal to 3y. Then I've got to get rid of that pesky cos t. So looking at this, I might be able to get myself a formula where I can do, you know, the x squared plus y, sine squared plus cos squared is equal to 1. So let's go ahead and square everything in this one here. If I square everything, I'm going to get 4x squared cos squared t is equal to 9y squared. And I'll come back to this one here and say, all right, well, sine t is going to equal to x over 3. Actually, if I bring that over, it's going to be 1 take x over 3. So then sine squared t is going to equal to 1 take x over 3 all squared. So then, wait, I'm just going to do a line here just to cut that off there. So then I can say, well, okay, well, cos squared t is equal to 1 take sine squared t, like that there. So then if I do, let's think about this here. So I'm just going to go, so cos squared t is going to equal to 1 take x over 3 squared. All right, am I happy with that? That looks right. Just want to make sure I didn't stuff up back here. So bring that over there. That goes over there. Yeah. All right. So that looks good. So now what I'm going to do is I'm going to take that and put it into there. All right. Told you this would be a pretty fun question. So I've got 4x squared. And then I'm multiplying that by 1 take x over 3 all squared. And that's equal to 9y squared. Cool. Alrighty. Now, so supposedly this should, now this sort of looks like we're on the right track. Now keep in mind, we want to get ay squared. I'm going to get an ay squared. Oh, sorry, that should be a 3 there. That should have been a 4, sorry. Plus bx3 plus 4x4 is equal to 0. So let's see if we can get something like that there. Alrighty, so I'm just going to go to my class pad now. So I'm just going to go to new share, get my class pad, and now what I'm going to do is I'm going to take that left-hand side of that equation that I had previously there, and I'm going to simplify it. So I'm going to go action transformation. I want to expand, and then I want to simplify. Alrighty, what did we have? We had 4x all squared multiplied by 1 take brackets 1 take x over 3 all squared cool. So I'm just going to write that down. So I've got it here. So minus 4x4 over 9 plus 8x cubed over 3. Cool. So I'm just going to remember that there. So let's come back to our page over here. So we said that that's going to give us 4x4 over 9 take 8x 3 over 3 is equal to 9y squared. Cool. Alrighty, now if I multiply everything by 9, it'll get rid of all the fractions. So still getting used to this. 4x4 taken and multiplied by 3, 24x cubed is equal to 81y squared. We're going to make it all equal to 0. So what we've got here, we'll start with the y squared term first, minus 81y squared. Take 24x cubed plus 4x4 is equal to 0. All right, this one here matches this one here now. All right, so there is our A term here. There is our B term here. So we can say that A is equal to minus 81, B is equal to minus 24. What good fun. So 4 marks for that there. Probably took me about 5 or 6 minutes. Anyway, again, pretty challenging ending to a question, but that's what you sort of need to expect. So you always start out with something nice and easy. Parts A and B should have been 4 marks. Part C was relatively easy as well. That only took 2 minutes to do that one there. And then part D, something quite challenging. for that there. Anyway, have a go at chapter 7b. I'll do some other examples for you to help you with that on your way. Cool. Thanks, guys.